Let's move on to testing, which is basically the long forgotten step in the software cycle. And what I mean by this is that testing a lot of times is not done properly, and a lot of times it's just not done at all. And this is due to a couple of different things. One of the main reasons for this is that testing is very difficult. To find out exactly how your program works and to figure out what's wrong and what's right is something that's difficult to do. And a lot of people like to just release it to the public and let the public be basically testers. And I mean, that is a way to do it. But you can get bad perceptions of your programs if you do that, especially video games. If video games are released with a ton of bugs, a lot of times people will refund the game or they'll abandon the entire franchise because of the bugs. Having a solid testing strategy in place is very paramount to making sure that your product is released with the most quality that it can have. Because even if we built everything about 90%, if 10% of things break the program or slow the program down unnecessarily or create errors that we have to go through, it's deemed basically a bad piece of work and people will move on. There's so much software out there that people will just move to the next one. So the testing process is very, very important. People also will abandon this step because of time crunches. If there's a due date, testing is usually at the end of the software lifecycle. That means that if the due date's coming up, people will basically skip that last part. They'll skip the testing part before they actually release it. And again, that's how bugs are created. So both these things contribute to testing being forgotten. People don't usually do it, but it is extremely important. So testing is the process of finding errors. It's very, very simple. All we're trying to do is we're trying to see if our program does what we want our program to do. We can test basically everything. We can test the code itself, which is what a lot of testing is actually running the program, figuring out if it works. We can test the implementations, so going through different ways of basically how the data is being put together. How is the, data from the server being transferred over? Is it coming through basically with full integrity, meaning that if an update happens to the server, is that happening on the local client? Are things working exactly how they should? We can even test the documentation. We can look in the documentation even before we begin programming, and we can test whether the plan is something that is smart, whether it could be refined, whether it's going to work later on when we actually begin building it. And we can even test other testing, because if we have a bad testing software, if we have software up here that even if we put an input, it's not giving the correct output, it's going the wrong direction or something like that, well, that's pretty bad, because that means all of our tests, basically we'll have a good program, it'll say it's bad and we'll change it to a bad program. So we can even create testing for other testing. And here's a neat little graph that I found. Provided by this college, UIC, right here. And this is sort of an idea about how testing might be done. So we can either do it in that sort of what's going to be known as the waterfall method when we talk about method or ways of developing software, where we go one step, then the next step, then the next step, then the next step. Or we can even do it like this. And here we are at the requirement step. And also the system specifications. Remember specifications and requirements? Well, we can actually do an acceptance test plan, which means we're testing whether this is even something that we want to create. Then once we get into the specifications, we go to the design. Remember talking about design, and then we can start discussing the system integration test plan. So what is the plan that we're going to use to test the acceptance? What's the plan we're going to use to test the integration? And then we're actually going to decide, with this, how is this a proper use? Is this what we want to continue with? Then once we get into the detailed design, then we start looking at subsystem testing integration. So again, we're planning the actual integration tests. And so you can see that during this whole step, we're not only doing a little bit of testing, we're also doing a major amount of test planning. So we're planning what tests we should be implementing with each step that we go through. Then we have module and unit code tests, and that's of course after the detailed design, after we start building it. And then once we've built it, we can then go through the testing. And this is, again, sort of the waterfall method where we're just going step by step by step, except these plans are then implemented down into these steps. So we start testing the subsystems, then the larger systems, and then whether it actually does what we want it to do. So we're going to test, basically, it's going to go from like a bottom up method. So we're testing the very small, the cores, the lines of code. And then we're going to see if the lines of code integrate well and actually start transferring data how we intended them. And then finally, we're seeing Well, okay, we have this piece of software. Is it doing what we set out for it to do? If we set out to create a word processor and we never check the requirements again, and by the end of it we have a spreadsheet manager, well, I don't care how, few bugs it has, it doesn't actually accomplish the basically the problem that we set out to accomplish. It's something completely different. So we need to make sure that it's still accomplishing what we want to, and then it gets released. We have a couple of key words throughout this. So the key words are going to be test data, test cases, and then Oracle. So what these they are basically common terminology. The test data is the inputs that are designed to test the system. So whenever we're testing for something, we have a set of inputs. We're trying something out, and that's going to be the test data. Even the test data doesn't have to be like text or numbers. It can be a sequence of steps that we do. So for example, if we're doing a financial transaction, it could be paying through PayPal. It could be paying through a credit card. That could be the input, the way that we're going to be doing it. And then with that test data, we can then create test cases and ways in which we operate the system with the given data. And again, these two sort of go a little bit hand in hand. So if we were doing that financial thing, maybe the test case would be using PayPal and the test data would be a known good and a known bad credit card. But these two together are what we're going to be using. These are the inputs and the way of using the inputs that we're going to be using to test the system. And then finally, we need to know, is it a good outcome or a bad outcome? And that's what the Oracle is. It's sort of a unique terminology for computer science here, in that we use the Oracle for the set of good outcomes. So whenever we test something, we need to have something to compare it to. For example, if we built a really complex calculator and it's supposed to be doing these math problems, maybe I don't know how these math problems work. So I need a sheet of paper to tell me I should be able to enter in this math equation and it should be able to give me this outcome. If I don't have that sheet of paper, it doesn't matter how much I put in. If I don't know what the expected outcome is, how do I compare it to see if it's actually good? And these all sort of link up in different ways. So usually we start off with something up here where it's like the test cases. So we start off with, what are we going to test? What are the things that we need to test? And with this, we then end up with the inputs, or the test data. And then we also have to come up with a sort of an expected output. So what is the output, the good output? And then, or let's make sure that we put this as expected. A little sloppy, but that's expected output there. So with the test data, we're going to then run it under, basically we're going to put the software under test. So we're actually going to do the test. And then with that, we're going to get some output here. And then with this output, we're going to compare it to the expected output. And what is our expected output? Well, that's the Oracle. So the Oracle is right here. And then with the test data, we need to understand what was the input to see what the proper output was. So if we have the Oracle of input, output, so we have input, output, and this is sort of the Oracle here. This line of code should be this should be, that, etc. We need the input data to see what the output data is. So that's our test data as well, goes to the Oracle. Our expected output is the right side. Then we compare it with the output coming in. So the output comes in, we look at the comparison, and we create the test. So this is just sort of a little flow of how this should work here. Again, we have test cases, which goes to test data and expected output. The test data is then put into a test, so we actually run the test. It gets output, we compare it to the Oracle to see if it's good. And that's sort of the overview of testing. And now let's sort of dive into some more of the importance of testing and different ways we can do it.